So we're going to start the machine. The first step in starting the machine is to go to the rotary breaker, which is right here, and turn it on. At that point right here, the little LCD ABC screen will put our operator number in. Now we have the ABCD screen. Turn on machine, select clock, parameter setup, or parameter reset. As an operator, all we're concerned with is turning the machine on. We press A. It asks us for the shop order number. We put that in. The next step asks us for normal welding or EMP. Today we're going to be normal welding, so we'll press A. It asks us to press the start-stop button. That's right here. We're going to press the start-stop button. And now the ABCD screen says ARC stop, and it has to say that right now. It was a self-test procedure. If it doesn't say ARC fault, you need to call the supervisor and find out what's going on. If it does say that, we go down here to the restore button and hit restore. The machine is now ready for running. And the first display on the machine on the top left is for pressure. This is the amount of downforce we have while we're welding. It's in bar of pressure, so it goes anywhere from 0.1 bar all the way to 6 bar. It's adjustable plus and minus, and you can go from there. The next display in is for welding time. This is the amount of time that the RF is on during our weld cycle. This will be adjustable according to product, and you guys will have to do some empirical testing and some experimenting to find out what works best for each product. Then the next display in here is for our RF power. The display right here is for the percentage of power that we're requiring. When the RF comes on, that percentage of power will be displayed in this LCD screen right here. The next display in is for cooling time. The cooling time usually matches the welding time unless the welding time gets excessive, in which case we can still keep the cooling time down. But rule of thumb says we match the two together. The next display is for energy square. Today we're not running in energy square, we're running in regular welding mode, so that will be discussed at a later date. The next display is for bar temperature. The bar temp is the temperature that the bar is held at, or we try to hold it at. We have a cooling system and a heating system. We have oil running through the bar, and we try to keep it at a certain temperature. The next display is for transport count. It's the distance the machine moves when we're in auto travel mode. The next button in is our emergency stop right in the middle. To stop the machine, we hit the button, it'll lock. To unlock it, we have to rotate and let it release. This is our LCD, or our ABCD screen. It gives us our choices of what to do and how to run the machine. And the next is our input pad that goes to the display screen. Starting with the numerous buttons that run across the bottom of the machine. On the top and bottom left and on the top and bottom right are our laser on and off according to which side we're turning on, front and back. Our top second button on the left and our top second button on the right are program direction. If we're in an automatic mode and the machine is going to move in an automatic function, this tells us which direction we're going to move in. So if that light is lit up here, we'll be moving right. If the light here, we'll be moving left. That can be changed numerous ways. The joystick will change that. The little movements at the top will change it, or you can just touch the program right or program left button. The next button in is a slow left and a slow right. They do the same thing as the buttons here do and the joystick do. So there's 3 different ways to move the machine. The next button in is an automatic return. We have an automatic return left and an automatic return right. When we press this button, the machine will go to its home position, as so. The next button in is a supplementary tool setting button. That goes with a different button, and we'll talk about that at a later time. The next button in is counter on. When the counter on button is on, the transport count display will have the number in it that we're going to transport automatically. If we press transport start, we're going to move that distance automatically and the machine will stop. And if we reverse our program to go the other direction and hit transport start again, it'll go back the same amount that we took off from. The center button on the top is the stop button. It's a cycle stop button. This is emergency stop. This is cycle stop. Cycle stop will not require you to restart the machine. It will just require you to restore the machine. There are 3 cycle stops on the machine. There's one right here, and then there's a yellow cycle stop button on either side. The next button is press auto and transport auto. These 2 buttons have to do with the machine moving and indexing up and down in an automatic mode. When the transport auto button is on and the press comes up, it will automatically move the transport count distance in whatever direction you have it programmed. If the press auto is on also, when it gets to the end of that position, the press will automatically fire, come down, and the RF will automatically come on. So this is our semi-auto, auto, and if they're both off, we're in manual function. An automatic program function right here gives us 4 different programs that we can run. We'll discuss them at a later time. Going across the bottom, the button right here is a bar temp on. This allows us to monitor the temperature of the bar and try to control it via the heat or the cooling system. The next button is our tool open button. The tool open button allows us to change our tool quickly. We press the button, you can hear the clamp open. We're able to slide the tool out and back in, put the new one in. We want to line it up to the middle of the bar, close the tool. The next 2 buttons here are actually just lights. One is a filter fault light, one is a flash fault light. The flash fault light is either an arc fault or an overload. The filter fault light comes on, you need to call the maintenance guy, he needs to do maintenance on the machine. The center button on the bottom below the cycle stop is the restore button. This is the button you'll have to hit in the case you get a fault and you need to get out of that fault cycle. You need to let the machine know that you have acknowledged the fault and that you're restoring the machine back. The next light in is the HF on light. When the RF comes on, that light will also come on. These 3 buttons are tied together: HF auto tuning, HF on, and HF auto. We will be running with them on 99% of the time. All 3 lights will be on. There will be an occasion when we won't use them, but we'll discuss that on an individual basis. We have joysticks to move the machine, and we have up here to move the machine, and then we have to index the machine up and down. So we're going to make our first weld today, and we've already lined our material up. We have some lasers to help us line the material. You'll be able to see them better when you're in person working on the machine. We're ready to make our first weld. We're going to bring the bar down, and we're going to notice that in the back we have another device that comes down. That's called our grounding foot. So we want the grounding foot to be flat as possible on the table. Doing something by leaving the sandbag in there that helps us hold our material in place, or leaving our material bunched up in here, will cause us major problems during the RF cycle. It will cause us to have some burns and arcs in the grounding foot. It will also, if we get lucky and don't have a burn or arc in the grounding foot, it will cause the RF not to penetrate the material as well as it's supposed to, and will affect the integrity of the weld right here. So a weld done with the grounding foot messed up like this, and a weld done with the grounding foot proper will be 2 different welds. So we need to make sure, just for the integrity of the weld alone, that we don't do something like that, let alone the safety of everybody around. We're going to make our first weld. We've already lined our material up with our lasers, and we've already decided on a program to run. In order to get the RF to come on, I'm going to push one hand button and bring the head down. I'm going to need to hold that until I see that come up to there. Now as soon as the 40 gets matched, the timer will start to run. At the end of the cycle, the head will come up, and just wait here for me to tell it what to do next, because we are not in any kind of auto function. Doing that same cycle again, if I put transport auto on and I tell it to transport to the left, I bring the head down. We're going to weld. As soon as we're done welding, the head is going to come up and it's going to travel to the left to describe the index in the transport count screen. So that would be a semi-auto function way of running the machine. The third way to run the machine would be in fully automatic, where I would have transport auto on and the press auto button on also. At this point, I bring the head down. I wait for the LCD light to light up. I can let go. Now my job is to get in front of the machine and make sure I align my materials as the machine comes to me. It's going to finish its cycle, it's going to come up, come towards me, and the head is going to come down again. So I'll make any last minute adjustments I need to make here in order to get a good weld. And it'll do that all the way down the table until we're done with our weld. So we have a situation here where we've already welded up to here, and I have this much more to go, but I have a bigger bar in there. And what's going to happen if I just bring the bar down right now and weld right here? Big circle with a red line. No good. We don't want to do that. We have a great chance to arc or burn right here and destroy the buffer and or the bar. So the right way to do this would be to have two pieces of the same material that we're welding on the machine right now, put them in there and make as small a gap as possible in here, and now bring the head down and finish our weld. That would be the proper way to do that. Okay. A situation might arise where we have only that much material. So our overlap, instead of being a 1/2 inch, maybe 2 or 3 inches. In that case, it would probably be proper or okay to just back the machine up and line up your end here and just have a little bit bigger overlap right here. But if we're going more than 30% or 25% right here, then we need to just go ahead and put a second piece of material out here. And the reason is that the machine is set up for the welds with a small overlap. As we continue to grow the overlap, we're actually changing the value of the weld that's in here as compared to over here. So the right way to do it is to put the spare piece of material in place, the exact same thickness and exact same material that we're welding together, unless the overlap is very small, in which case we'll just overlap a little bit bigger than normal. So the machine, while we're operating it and we're loading our material, as you can see, I'm touching the bar, the machine is in the on condition, and I'm able to touch the bar as much as I want. But as soon as I bring the head down and we get into an RF weld mode where we have power in here, that is the time that you do not want to touch the machine at all. You want to make sure you keep your distance from the machine, at least standing right here. We don't want to reach in. If you left a pair of scissors behind or a pencil behind or something, wait for the cycle to end and then reach in and get it, because if you reach in too fast and you get too close to the bar, the RF might jump off the bar and burn your hand, and we want to be as safe as possible. So if we left something behind, we get it later. Otherwise, we engage the machine, get the RF started, and as an operator, the right thing to do would be moving down here to our next station. So we're, as you can see now, we're plenty far from the machine, that we're in a very safe position. How often should we clean the bar? The bar should be cleaned every time we get a burn. And we do RF weld, and the RF welding is the best way to bond two pieces of vinyl together. The downside of RF welding is we do get flashes and burns. So anytime you get a burn, you're going to need to take your bar out of the tool holder. You'll need to turn it over and examine the bar. And you'll be looking for damage on the bar. Any damage on the bar should show up as a small pit. If it's just a little small mark, it looks like a pencil mark on it, then that's normal and acceptable damage to the bar. You'll need to sand out the sharp spots, clean out the carbon, and put the bar back in. You'll also, at that point, need to examine your buffer and see if the buffer was damaged to the point where it needs to be replaced or repaired. Okay? If you pull the bar out and it looks like it was shot with a .22 gun, that means the arc suppressor inside the machine did not function properly. We need to stop and have the service guys or the maintenance man come take a look at the machine and make sure that the arc suppressor is working. Okay? So the damage to the bar during a burn should be very minimal. It should almost look like a pencil mark. And we've seen a couple today already, and you guys kind of know what they look like already. But that should be it. You shouldn't see anything much bigger than that. So after we inspect the bar and repair the bar, we put the bar back in the tool holder. We'll move the machine out of the way. We'll go to the spot that burned on the table, and we will inspect our buffer to make sure that we don't have too much damage or any damage to the buffer. If we think it's going to burn there again, we need to call the maintenance man, or we need to take the right steps to replace the buffer. We're now going to level the tool. There comes times when you get a different tool in-house that may not be the same, or maybe the machine changes over time and we need to re-level the bar so that we have a flat, even weld, front to back and left to right. So the procedure for that is as follows. The first thing we do is turn off the HF auto tuning button. The second thing we turn off is the first and only 3-pole breaker on the machine. We go to our welding time and we turn it up to 15 seconds. We go to our cooling time and turn it up to 15 seconds. We turn our bar pressure to 6 bar. We bring the press down. We don't need material in here right now. The 3-pole breaker has turned off the RF. The machine is perfectly safe to work around. We'll double check and make sure that breaker's off, and it is. Now we bring the press down. As soon as that HF light comes on, I know I'm under full pressure. At that point, with my hands, I crack these 4 screws loose on top. And I make sure there's a little space in each one. I hit the restore button, and I bring the head back up. And as you can see, that space has now disappeared. The next time I bring it down, it's going to go in, when it goes into high pressure, you'll see that space pop down. That will have leveled the bar. The bar only gets pressed on from one center point in the middle here. So the bar will automatically level itself to the plate below. So here we go. You hear the little clunk, you can see the space. The same guy goes back in and tightens these 4 back up by hand. We have now leveled the bar. When we finish this, we need to go back in and change our timers and turn on our power again. So we have the guiding screws right here, and they are to adjust the bar from being out of place and dog tracking down and make sure that end to end is straight. If you find your jobs are end to end and out, you need to call the maintenance man. He'll need to readjust these. The hoses out front are 2 air hoses and the oil hose. The oil hose contains the heated or cooled oil that we use to control the temperature of the bar, and the air hoses are for the clamp that opens and closes. This is the regulator that supplies the air to the machine. In order for the air to be going to the machine, we'll need to turn the regulator on by pulling this switch up. We should have 7 bar of air at the regulator. Periodically through the day, you might want to just glance over this, make sure that we're there, make sure that we haven't lost pressure in the building somewhere. Okay. In summary, we pretty much learned how to weld today a little bit. You'll get practice on the machine. You'll get some personal instruction from some experienced people. If and when you are operating the machine by yourself, the machine doesn't operate in the fashion that we've told you. You hear some strange noises, you see smoke, anything out of the ordinary. You need to stop the machine and get somebody to look at it right away. We don't want to damage the machine. We want to make sure the machine stays in good shape for everybody to use. So anything that doesn't seem right, better to ask questions now and say it's okay than to ignore it and have it do a lot of damage.